Hello everyone. Today we will discuss about some lines. Here we have all the values are 1, which is known as solid line. Then we have the dotted line or dusted line. The dotted line is here we have 1 0 0 1 0 0 1 0 0. Those are known as dotted line, and dashed line are for 1 1 1 0 0 0 1 1 1 0 0 0. And this one is the self-defined, and this can be changed. In the scan conversation, here we will draw a circle. In the circle, first of all, we need to divide them into 7 segments. Okay, here we have 8 segments, but here we have more than 7 symmetric points. In this discussion, we have first the value, the first segment, which is xy, then this section is yx, this one is y minus x minus xy, and so on. Here we can see that those points are opposite. Here we have xy, which is the plus section. Here in the opposite direction we have minus x minus y. Here we have yx. In the opposite direction we have minus y minus x. Here we have y minus x. In the opposite direction we have x minus y. Here only 45 degrees scan conversation points in the symmetrical points will be computed the circle during drawing. Here we have the first method of the equation. Here x square plus y square equals to r square, which is the general formula of the circle. Here we have y square equals to r minus x square, and finally y equals to root over r square minus x square. Here x denotes the x coordinate, y is the y coordinate, and r is the radius of the circle. If the value of x n we could be able to compute the y, then we can get a point which is b. Then we need to compute all the coordinates from only the curve BC and find all the symmetrics. Here we have the value of x and y, which is crossing at the point A. Here we have the steps how to draw. Set the x to 0 and compute the y. Draw the 8 points using the symmetry. Then increase the value of x by 1 and compute the y. Draw the 8 points using symmetry. Repeat the step 2 until we have OA or the x. Here we have the second method of drawing, which is trigonometric function. Here the phenomena are x equals to r cos theta, y equals to r sin theta. For these functions, we have those calculations needed. Here are the organization and the working steps algorithm. Now here we have discussed about pi. Here is our Besselhelm circle algorithm. By applying this Bresselham circle algorithm, we can draw a circle very easily and very convenient way. So from the exam question point of view, the Bresselham circle drawing algorithm is very important. Here, points are generated by from 90° to 45° and 8 symmetry are considered. Here we have made only the value plus x and minus y direction. The steps are given here. Let we are at the point xi and yi, which is the initial point. Then set the value of x, which is x plus 1, and y remaining the same. Then the point is x1, y1, and set the point x2 equals to xi plus 1 and y2 equals to y minus 1, which is the point x2, y2. Then the distance of the origin t equals to r1 equals to x1 square plus y1 square. Here we have find the distance from the center, which is r1, and distance of t from the true circle is dt, which is r1 minus r is from this formula, and so on. Distances are calculated here. Here we can see that first you need to identify the value of d. Here, if y plus 1 equals y, then the di plus 1 is di plus 4x plus 6. If the y plus 1 is equals to y minus 1, di plus 1 equals to di plus 4 into xi minus yi plus 10. From calculating the value d1, we use this formula, which is 3 minus 2r. Here r is the radius. So first of all, in the Bresselham algorithm for circle drawing, we need to find the d1, which is 3 minus 2r. Then the di plus 1 will be, if the 0 is greater than the d1, we will put the value of d equals to di plus 4x plus 6, and if the value of di is greater than the 0, then we will put the value di plus xi minus yi into 4 plus 10. You can have a snap of the slide. Those formulas are important for your examination question point of view. Now we will understand the coding. Here we have set the value of x is 0 and y is r. So the d equals to 3 minus 2r. While y is greater than the x, then set the pixel xy. If the 0 is greater than the d, then we will put this formula, else we will put this formula. Y will be decremented and lastly x will be incremented. This is the coding for Bresselham's circle drawing algorithm. Now, the midpoint circle drawing algorithm. The midpoint circle drawing algorithm will quite same as the Bresselham algorithm. Here, if we zoom in, we can see those points in the midpoint section. Here we have some conditions. If the 0 is greater than, then it will inside in the circle. If it is 0, then it is on the circle, and if the value is greater than 0, that's why it is out of the circle. In this coding section, in the midpoint, we define x equals to 0 and y equals to r. Here, we need to count the p equals to 1 minus r is the radius. If the value of y is greater than the x, then we set pixel xy, and if the value of p is less than 0, then we will put this formula, which is p equals to p plus 2x plus 3. Else, we will put this formula, decrease the value of y, increase the value of x. By this coding section, you can generally implement the midpoint algorithm. Now, defining the ellipse. This one is the polynomial method of drawing ellipse. This one is the formula of ellipse drawing. Here, A is the length of major axis and B is the length of minor axis. A is the major axis and B is the minor axis, and H is the height. Those are the steps to count the ellipse. By the Brasselham algorithm, we can generally draw an arc also. That is how the arc looks like. This one is the shape of a sector. Defining the rectangle, this one is the rectangle shape, and that is how we can draw a rectangle. Xi is the initial, x1 is the starting point, which is denoted as x1 and y1, 2 the x1 and y2. That means we have first incremented the line value just only this side, that means the y side, and then the next line is drawn from x1 y2 to the x2 y2. That is how we can generate a rectangle. Here we have line 1, line 2, line 3 and line 4. Here we have, for this coding, line 1, line 2, line 3 and line 4 to draw a rectangle. Scan conversation characters are given here. We will discuss them into our next slide. That's for today. Thank you.